In this lesson, we're going to examine properties that will help us expand and condense logarithms. So I want to remind you of exponential properties that you're very familiar with. When we have like bases and we have a product, we keep our base and we add our exponents. So since logs and exponents are inverses of one another, it should not be surprising to you that the following property holds, that log base b of this product, x times y, is equivalent to log base b of x plus log base b of y. Similarly, when we have a quotient, we've learned keep your base and subtract your exponents. So when we have log base b of a quotient, we can separate this into two where we subtract the numerator minus the denominator. And when we have power to a power, we've learned keep your base and multiply your exponents. Similarly, if we have log base b of x raised to a power, remember this produces an exponent raised to another power. This separates into that power times our log. So let's try to use these properties to follow the directions on your screen. It says express each log in terms of log 2 and log 3. So to even attempt this, I'm going to break down 96 into primes so that I can see, well, 2 and 3 are primes, so I want to see what this breaks into. So I have, let's see, you do enough of these, you'll be able to do some of them in your head. I get 2 to the 5th times 3. So I'm going to rewrite my argument here as 2 to the 5th times 3. And now I'm going to separate using my rules. So I have a product, so I know that it can be written with the same base. Well, this is the common log, which is base 10, log 2 to the 5th plus log of 3. Okay. Now I want to keep going until all my arguments are like just a single value. So I want to use this 5 right here. This is a log of 2 to the 5th. So this 2 to the 5th, remember this produces an exponent, it would be raised to the 5th. I'm going to bring this out to the front, make it a product, implementing my power rule. So I would have 5 times the log of 2 plus the log of 3. Okay, now one of the things I would encourage you to do is type the original into your calculator, because your calculator can do that, and type your answer and make sure that the decimal you put is identical. Take a second and do that. All right, let's break this one down. Same instructions to write it as log of 2 and 3. So I have a quotient, so I'm going to make this log of 32 minus log of 9 using my quotient rule. Remember, when we're dividing exponents, we keep our base and we subtract. Similarly with logs, when we have a log, we have a quotient, we separate it into two subtractions with the same base. Now, log of 32, I know that 32 from the previous one we just did was 2 to the 5th. That was part of my factor tree. And I can break down 9 in my head. That's 3 times 3, or 3 squared. Okay, so now I have raised to a power. Power rule says it's going to become multiplication. So I'm going to multiply each log by that exponent. So I'll have 5 times log of 2 minus 2 times log of 3. Again, I would encourage you to type your original into the calculator and this answer, and make sure that you have equivalent expressions. So why are you doing this? Well, in this particular one, there's not a whole lot of real-life scenarios where you would break it down to a lower prime. However, sometimes it's easier to figure out in your head without a calculator, which I'll illustrate in the next one. It really just shows how you can use the rules. So in this next one, we're told to evaluate. So let me show you how these rules can help you. So log base 2 of the cube root of 32. I don't know the cube root of 32. It's not, because 32 is not a perfect cube. But here's what I'm going to do. I'm going to first rewrite 32 as 32 to the 1/3 power. That would be its equivalent rational exponent form. And now I can use my power rule, where I would have 1/3 times the log base 2 of 32. And now I know log base 2 of 32. If you think about this, remember, what are we doing? We're thinking 2 to what power is equal to 32? Well, I just several times in this video alone saw that it was 2 to the 5th power, so I can replace this part with 5. And now I have 1/3 times 5, and what's that? That's just 5/3. In our next one, I have the natural log, and the rules that applied for just other logs apply here because the ln is just a log with a base of e. Okay, so 3 times the ln of e to the 4th. Okay, well, first of all, I'm going to apply my power rule on both parts of this expression here. And I'm going to bring the 4 out front to multiply. So I'd have 4 times 3, which would be 12, times the ln of e, minus 2 times 2 would be 4 times the ln of e. Now, what's the ln of e? Remember that that's equivalent to having a log of base e, and it's saying e to then what power is equal to e? E to what power is equal to e? Well, this is 1. Okay, so the ln of e, you can think of them as inverses. They're undoing each other. You get 1 and 1. So I have 4 times 1 here, 12 times 1 here. I didn't mean to put an equal, meant to write a minus. 12 times 1 minus 4 times 1 is just 8. This one, I'm going to expand this, just showing how to use my rules. So as part of my argument, I see that I can kind of break this into 3. I have 3 factors as part of my argument. So I can use my product rule, which would say the ln of 4 plus the ln of m to the 3rd plus the ln of n to the 5th. So I use some color coding there so you can see which each part breaks into. And now on 2 of these, I have an exponent up here that I can use my power rule. So I'll just recopy this ln of 4 plus I would have 3 times the ln of m plus 5 times the ln of n. And I can't expand this any further. So this is expanded. And why are we doing this? Well, you're going to see once we get to solving equations, it's going to make it more manageable to implement these rules. All right, log of a quotient. So I'm going to use my quotient rule to start, which would be log of 2x minus 3 minus the log of, and you know what, I'm going to make this in its rational exponent form right away, making that x to the 1/4. Okay, now this first one, I can't split this up anymore because I have like a binomial here. I have both a product and a difference that I'm taking the log of. This one, I have a log, which is an exponent raised to another power. So think about power to a power. What do? We multiply. So I bring this out front using a multiplication rule. So I have 1/4 times log of x, and I'll just recopy this first part, log of 2x minus 3. And I put that log in parentheses there because I don't want you to think that it's log of 2x and then you're subtracting 3 from that. No, this is the whole argument, so that's why these parentheses are necessary. Okay, so let's go the other direction now. Now we're going to condense, okay? So thinking kind of in the reverse direction. So I have this 1/2 and this 3 out front that's being held by multiplication. So I know that this is my power rule, just kind of doing it in reverse. So it'd be log base 4 of x to the 1/2 power minus log base 4 of x minus 2 to the 3rd power. Okay. Now I have the same base with my logs, so I can condense this further. Since this is subtraction, I can make this log base 4 of, now in the numerator would be the first argument, which is the x to the 1/2. I'm also just going to show that that's the square root of x, and then my denominator would be my second argument, which is this right here. So that's x minus 2 to the 3rd. Okay, so this is in condensed form. Now I have one with the natural log. So again, I have this product. So I'm going to make that an exponent. So power to a power rule, really. So the ln of x plus 1 to the 5th power plus 6. Nope, let me take care of that 6 right away. ln of x to the 6th. And now I have logs with the same base, because the base would be e, natural log here. So it's addition, so that would be my power rule, where I keep my same base, keep that ln of e, and it would be the same as multiplying together here. So it would have been x plus 1 to the 5th times x to the 6th. There would be my whole argument. If you have any questions, please reach out to your facilitator.